Hi, I'm in need of a new 3D printer. The last one that I built is okay, but it was never at the 100% that it could have been and has slowly declined over time, and now it feels like more maintenance than actual printing. I don't feel like it's worth trying to fix it, so I am building an entirely new one, and in this video I want to go over my first steps towards my new CoreXY printer. I've never owned or worked with a CoreXY style printer, but I always liked the idea and the functionality of them. And because of this, I just started with only the CoreXY stage to see if it works as intended and then plan the rest of the machine later. And since I don't have a functional printer right now, only a CNC machine, I'm milling all of the parts. So it's a what you could maybe call a mostly CNC 3D printer. So this stage is quite important for me as I have a first test assembly and I can see how it really looks like. The belt tensioners here in the front, they are quite far along the iteration pathway. Also the X-axis connectors, I'm quite happy with those. But the motor holders here in the back, they are still in like this is the second iteration, and I already see some issues. But this is a lot easier now that I can assemble it and have it in front of me. This stage I also want to use to check some important dimensions. I wanted to make sure that the belts are running perpendicular and also parallel to each other. And with some of the dimensions on here, I wasn't 100% sure because I just got them off the internet. And yeah, there's always some slight variation. As just briefly mentioned, the CoreXY stage basically consists out of 3 parts: belt tension, X-axis connector, and the motor holder. And they are mirrored on the other side. This means that I only have to design one part or one half of it. I think most dimensions look fairly good. There are some slight deviations in the belts aligning on this axis, but I think it's not enough to machine new ones, at least not right now. The only parts that really need some work is the belt tensioner. Here there's not enough gap for the belt here along this wall, and also the belt catches here right in the when the motor loops around it. So this is what I will fix in the next iteration. One of the last things is that right now it takes quite a bit of force to move the stage in the middle. I'm not completely certain where this comes from, but I will go into that once I've redesigned or finished the design for the motor holder, which I will do next. So now that I've updated the G-code, it's time to get the stock ready, and it looks like I would have just enough, 2 for the left side and 2 for the right side, if I don't mess anything up. But let's see. For the design, I took inspiration from the Warren as well as the Prusa XL, but ended up designing all parts completely custom, also with the aim for the parts to be machined and not 3D printed. And as always, I will put the files to access on my GitHub. I also decided to go with aluminum extrusion, and this mostly to be a bit more flexible with the overall dimensions, and right now I'm aiming for a 250 by 250 millimeter build surface. So this is the motor holder part that you just saw me machining and the design that I decided to go with. I added some clearance and also made the remaining missing parts. When testing the earlier parts, I noticed a lot of chatter when surfacing the top because of insufficient work holding. To fix this, I clamped the part more tightly, which helped a little, but also meant that I bent some of the pieces, especially here in the center. For the final two parts, I changed how I hold onto the part, and this improved the surface finish without any bending. I would like to remill the bent parts, but I don't have any material left. And it's also a good reminder for me that chasing perfection takes a lot of time and can slow down the progress, so I try to live with these imperfections and move forward, even though I will always know that they're there. The motor holder itself is made out of two parts, and lower and upper half, which are held together by 3 screws, and also by the motor that is fixed through both parts. The motor here is recessed for better belt engagement. The belt runs along bearings mounted on these really long shoulder bolts, so they don't have to ride on top of a thread. Getting these bolts was harder than I expected, and they had quite a long lead time. I was also hoping for better dimensional accuracy and a tighter fit for the bearings, as there's noticeable play. I even purchased a reamer to get the milled parts as close as possible, but I don't think that it was necessary. For the bearings itself, I'm using these flanged ones called F695ZZ. The axis connector is made out of 3 components. The top part, which holds onto the Y-axis carriage, could also have been part of the main body, but I kept it separate to make it interchangeable for different size rail carriages. This way I can adapt it to smaller and larger carriages if needed. The main body connects to the X-axis extrusion and holds all the bolt tops. Together with the lower part, it clamps onto the extrusion and uses also the long shoulder bolts to guide and redirect the belt. On this part I'm also using a belt idler, as this is the only place where the belt's face has to make a turn. I'm not completely sure that this is necessary, because other designs, I think like the Prusa XL, seem to use just regular bearings here instead. The main body of the part took quite some time, not really because of the build itself, but because I had to do a lot of troubleshooting while milling the parts. I noticed some imprecise Z movements and an occasional audible ticking sound from the stepper motor. At first I thought it was the belt tension in the Z movement assembly, as I just had replaced the last 3D printed part on the machine. I tried setting the belt tighter and looser and eventually went back to where I started. I thought it was better, but later realized that the fault was an intermittent one, so not always occurring. I then wondered if it was backlash, so I tried reducing any Z movements during the cuts to sort of go around the problem. But as this didn't work as well, I thought that it could maybe be the work holding. These were the first pieces where I used superglue as a fixturing method, as I had plenty of 10.5mm stock and the parts themselves are 10mm thick. This worked fine most of the time, but here you can also clearly see what happens when the workpiece gets loose during a climb cut. The extra cutting caused by the Z-axis moving during the pass, and also I believe a bit of rubbing, generated quite a bit of heat, which then softened the glue of the tape and ultimately released the part. Finally, I thought it could be the motor driver, so I switched connectors and with that changed which axis is being run by which driver. And while doing that, I noticed that one of the wires going from the driver to the motor was loose within the connector. But the thing is that I hadn't touched any of these cables even when I replaced the controller in the last video. And before exchanging the controller, I had never seen this issue. So the wire must have been loose for quite some time, and it only caused an issue after I switched the controller, and while doing that likely moved things around and shifted the connection. After fixing the loose wire, the issues seemed to be resolved. But then it happened again, this time after about 10 parts without any issues. This time the motor also seemed to click quite regularly, and it only stopped when I disconnected the pulse signal from the CNC driver. That's when I knew that the problem was probably coming from the control board. I think the pulse generating loop within the controller sometimes hangs between 2 points or 2 values and tries to adjust itself. I tweaked the settings for the control loop and it improved. This part of the controller setup isn't great, and the only part where I'm not completely happy with, as it's not clear what the best way is to fine tune these values. I don't get good feedback when tuning these. I read that there's a software update available for the controller and that might help, but I will deal with that later. Also because I think the update could cause more problems that I'm trying to solve, so I will do it after I finish most of the parts for this build. So yeah, that troubleshooting took some while and I'm not convinced that it's completely gone, but the last 2 parts work just fine, but I will definitely keep an eye on it. The last part, the belt tensioner, is also made out of 3 parts. 2 of them from the main body, which also connects the aluminum extrusion pieces together. The third part slides into the main body and can move freely until it's tightened by a screw from the back. This is also what tensions the belts. I thought about adding a really stiff spring where the belt tensioning screw is to absorb some of the rougher movements, but I figured that would probably just cause more inaccuracy than help. For the centerpiece, the sort of business end of the printer, I'm just using a blank at the moment. Originally, I was pretty sure that I would just purchase a ready-made extruder and hot end combo, but after thinking about it, the extruder can also just be a piece of aluminum with some gears and a bit of cooling. So now I'm experimenting with building and designing the sort of cold side of the hot end. This has the added benefit that I can design the parts to the rest of the build and choose the dimensions that just fit best. The extruder will be the topic of the next video. For now, I will just use the blank that then holds the belts together. Other than that, I have all the parts that I need for my CoreXY stage, so I can begin the first real assembly. Even though I designed these parts, I'm not 100% certain what the best order of operations is to assemble. I think this is a whole nother level to try to make them look fairly good, make them do what they should do, and then also be easily or assembled in a good way. I think there I can still learn quite a lot. So now with all the belts, the assembly of the CoreXY stage is complete. Getting the belts everywhere, especially here looping around the drive shaft of the stepper motor, was a bit difficult, but with some small Allen keys as well as a bit of wire and tape to pull it through, it was manageable. So since it's a CoreXY stage, both of the motors are in the back and both drive one belt loop. Each of those belt loops are then moving both the X and Y axes. The belts go in two big loops around the entire frame and are connected on both ends in the center here. The left motor is pulling the center stage diagonally in this direction and the right motor diagonally in that direction, and by synchronizing how we move the motors, we can go in any direction we like. For our first bit of testing, I ripped out the motherboard from my old printer and I'm now powering with 18 volts. It can take, I think, 12 to 24, so 18 is right in the middle. I didn't change the configuration yet, so this board still thinks that this is a normal Cartesian XYZ printer. On the other side, I have my shop laptop with the Pronterface software running, so I can connect to the board to do really basic testing. And now if I set it to jog, it should. It should move. So as you can see, it does work. A bit jerky, and I haven't tried circles as the motherboard isn't configured correctly. I will do that as soon as I remember how to do it, because it has been a couple of years since I worked with flashing these kind of boards and the Marlin software. But I've played around with it a bit more and I can't see any unevenness or hiccups during the movement. So for me it works well enough to continue designing the rest of the machine. One of the next steps will be focusing on the extruder as well as the hot end, which will probably be the topic of the next video. See you then.